Hello and welcome back to Cracking the Cryptic for a bit more Sudoku fun and an intriguing grid with chunks of it covered in arrows. We'll have a look at that in a moment. I was very impressed and amused by a tweet from somebody saying that Countdown, who's losing their host Anne Robinson, who's announced her stepping down, should employ the CTC guys as hosts. And funnily enough, when the news came on the radio this morning, I was just trying to compute my chances of getting the job as host of Countdown, and I made it about 500,000 to 1. We shall see. We'd be a lot cheaper than Anne Robinson, I can tell you that, Countdown. But anyway, that tickled me this morning. Do check out the links. Patreon, of course. Yes, we've got 2 hunts running contemporaneously. We've got Quinlux's pretty tough build your own Sudoku hunt, and we have got the May Patreon reward, which is equal sum lines Sudoku, and we get about 100 correct entries a day to every 1 for the Quinlux hunt, I would say. That's the ratio, and that's probably a measure of their relative difficulty as well, or the fact that the equal sum lines is a bit newer. But do have a go at the equal sum lines hunt if you're a Patreon, or consider joining Patreon if you're not. There is a hard mode, but there is a normal mode, and it is proving approachable. So check that out if you're on Patreon. I will also at some point this week be posting a crossword video, which I think I said I would try to post last week. Didn't get it done. We will post it this week. It's the Very Hard Times monthly club special cryptic, and that will be coming soon. As long as I didn't post it already, I don't think I did. So that's coming up. Also, check out the links under the video for all our apps, for Sven's SUDOKU PAD, for the Discord server, for the catalogue of our videos, etc. But the first link will be to this puzzle, which is called Squarrows by a Walking Writer. Walking Writer has been contributing videos to the channel for features for, I'd say, a couple of years now, originally under the name Tom Presto. So that's been quite a lot of puzzles by them we've done. And this one combines squares and arrows. So I'm going to read the rules. The normal Sudoku rules apply. The digits along an arrow must sum to the number in the connecting pill or circle. And if it's the number in the pill, that's these 2-digit circles, as it were, you read them left to right or downwards as a 2-digit number. So if this was a 1 and a 3, that would be the number 13, for instance. So each number in the 4 highlighted pills, that's the ones in the corners, must be a perfect square, none of which can be repeated among those 4 pills. Digits connected by a white dot, there's only 2, must be consecutive, not all white dots are shown. So there we go, that's what we get. Sort of, it looks a bit to me like a sad clown face, this grid. I don't know if you can see that with the eyes, but I'm sure we will have a happy experience solving it. Do try it on the link under the video. Don't know how long this is going to take. It looks very interesting to me. I am going to have a go now. Let's get cracking. So, how do we get a handle or a start on this at all? I think we're going to have to think about relevant squares. I know what I'm going to do. I'm going to colour the cells on the arrows. So this one is adding those 6 cells. Obviously they can contain repeats, and the longer arrows they're clearly going to have to. Now, if it's adding those 6 cells, the most these 5 can add up to is 35, plus a 9 there is 44. So we don't get to 49, which is 7 squared. The least these can add up to is 9 plus 1, 2, 3, 4, 19, plus 1 there is 20. So this pill is going to contain either 25, 5 squared, or 36. And this one's got a short arrow. I imagine that's going to be the same. Let's colour. So we've got, there's only a slight difference, although we don't have the given 9. So 5 cells here, 35 plus 9 and 9, I suppose. Oh, 53. So we could get up to 49 in this one. Bother. but otherwise, well, I mean the minimum, oh no, the minimum now is 15 there. Okay, plus 1 plus 1. At least that takes us above 16 to 17, so it can't be 16. So we've got either 25, 36 or 49 there, I reckon. Now, what about these ones in the corners with the longer arrows? So let's colour this stuff. Let's make that red, and let's make this one, I don't know, purple. So, oh no, purple. Purple is hideous for seeing the arrow underneath. I didn't know that. Orange is better. Okay. So these are covering a lot more cells. I presume 25 is going to be impossible. So yeah, minimum for those is 21. Minimum for these is another 6 there and 6 there. So we're up to 33 as a minimum. Ooh, so 36 would be difficult, but possible. That's interesting. So 36 is possible. Clearly 49. Ah, hang on. Oh, and I didn't think about this. What does using the actual numbers make as a difference in the boxes? Yeah, I didn't think about this. Maybe this is better. If we use 25 here, we've used up the digits 2 and 5. Now the minimum is 9, 1, 3, 4, 6. Which adds to 23, plus a 1 there is 24. Oh, okay, so there is a degree of freedom and we could make 25, but literally only just. Now down here, if we used 25, these would be at a minimum 1, 3, 4, 6, 7. What does that add to? 21. Plus 1 is 23. Ah, so it does work. 25 was nearly ruled out in both cases. That's really irritating. Right, so what was I saying? I was saying that the minimum here is 21 plus another 12, 33. So 36 is possible. Oh, 49 is not possible because of that 9 looking at that cell. Okay, so 36, 49, 64. Now, could it be 81? The maximum for those, now, if that was 8 and 1, the maximum is 9, 7, 6, 5, 4, 3. Which is 45 minus 11, 34, plus 24 in each of those, 48 and 34, 82, just over 81, so it, oh bother, so it can be 81. Where have I put the 1? Up there, 1 should be there. Right, so this can be 36, 64 or 81. This one, I suppose, actually it's going to be the same set of digits. Like there's more digits even here because there's 6 in that box, 3 there and a full 5 here. So, but again it can't be 49 because the 9 would see that cell. I think that's why the 9's there. So it's 36 or 64 or 81 again. It is exactly the same. It can't be 100 because that's a 3-digit sum which won't fit in the pill. Yeah, that's the limit. So what's this telling us? If that was only 25 or 36 and that was only 25 or 36, I'd be ruling possibilities out of here and here. Right. So my problem, I think, is that this looks like it can be 49. Now, can it? Can it really be 49? I haven't checked this out, taking out 4 and 9 from the calculation. So if that was 49, the maximum these could be is 8, 7, 6, 5, 3, because 4 and 9 would be placed in the box. 8, 7, 6, 5, 3 adds up to 29. Yes. Plus 9 and 9 is 47. It cannot be 49. That's exactly what I did want to prove. Right. Now, one of these is 25 and the other is 36. They can't repeat. So you've got a 5 and a 6 looking at that cell. So now 36 is not possible there. Actually, 36 isn't possible there anyway, because these are 25 and 36. So we can't have 36 in these two. Ah, and now look, one of these is 25, one of them is 36. In one case, there's a 6 in these cells, and they both see that cell, so this can't be a 6. So this one is 81. That makes this one 64. That 6 fixes this one as 25. Oh, surprisingly, the slightly bigger green is less than the slightly smaller yellow, which is 36. So we've got these numbers done. Ah, because these weren't squares, I wasn't looking at them, but I've just realised in 3 digits you're not going to get over 30. So this must be a 1-2 pair on the tens digits of these sad clown eyes. I don't think I can do any more than that with those at the moment. But now, so this is the smallest. This seems to be the most constrained. 25 is made up of a minimum here of 1, 3, 4, 6, 7, which adds to 21. Right, so a maximum in these cells of 4. And this one can't be 1 or 2, so that's got to be a 3, and that's got to be a 1. This is definitely the right break-in. Okay, good news. Good nose, that's the good nose. Right, 3 and 1. These are 1, 3, 4, 6, 7, so this is an 8, 9 pair. And actually now, however I put 1, 3, 4, 6, 7 in these cells, this total is right. So I'm going to remove the colouring here because I've used it and I just don't need that anymore. This cell sees the 8, 9 pair as well as 1, 2, 4, 5, 6. So that's 3 or 7. I don't know. I don't think I can get very far looking at the possibilities here. So, what about this 36 then? I have a feeling this 81 might be helpful, but I'm going to look at the 36 first. The maximum for these... Oh no, look. Maximum minimum's not that useful actually, because... Oh, that's very interesting. If this... These cells add up to 36, the yellow ones, because that's what we know the total is. Plus the 2 blue ones is 45. So that total, you know the secret, 45 is the sum of every row, column and box in a Sudoku, because it's the sum of 1 to 9. So if that highlighted area is 45, and of course this highlighted area is 45, how do they differ? Well, they differ in that cell in one of them being those 2 in the other. So that total is the same as the total of those 2. And that's what we learn out of this region. And I think, so I'm going to colour those purple, uncolour those, and say that the 2 purples add up to the yellow. And once I get that right, I will have used this region, this colouring. So I'm taking out the colouring. Now, let's have a look at this 81. That is a big number. Now, the most that these can be is, and I did work this out before, if I put a 2 in there, that's 11 out of the 45, so 34, plus 27 here, no, 24 there, 987, is 58, plus 24 here is 82. Now, let me check that again. 34 here, if that was a 2. 987 there, 987 there, that's another 48, that's 82. There's only 1 degree of freedom. Right, and this one can't use the degree of freedom because it can't be a 3, so that's a 2. These are either... Oh, well, now we know that this does add up to 34. So one of these is 987 and one of them is 986. That must be right. Right, so there's an 8 in this group and we know where that goes. Actually, there's an 8 in this group and we know, oops, that group, and we know where it goes. So this pair can't have a 6, so that's the 9-7, and this is the 9-6. And now I can take out the red colouring because however I fill in box 7, it's right. The total is right for that arrow. Oh, that's fabulous. What a clever puzzle. Love it. Right, where does 1 go in the first column? Not there because of that. Not here because of the 1-2 pair. So it goes there. Actually, I can do 1 in this row as well because of that pair. Must be there. Oh, and that's helpful. Yeah, and even if those were both 9s, this isn't going above 19. So we get the 1 and the 2 done in the centre. Now we've got a 4, 7 to go in the bottom row. Oh, that 8 has seen that 9. Sorry if you've been shouting that at the screen. 3, 7 and 8 to fill in the final column. Now I'm fighting a bit shy of counting this 64 because I have a feeling it's a bit variable. Let's just see what the maximum and minimum are. Well, not the maximum. Let's see what the minimum is. So this could be 1, 2, 3, 5, 7, 8, which is 26. This could be 1, 2, 3, 4, 5, taking us up to 41. This could be, what, 3, 4, 2, taking us up to 50. There's still 14 degrees of freedom. The maximum's going to be far worse. So I can't really do much with orange yet. We'll get back to it. Yeah. Now, this is adding 3 cells that can see each other. So it was 6, 7, 8, or 9. Now it's 6, 7, or 9. And it's not 6 because we can't have a 3 on this arrow because of that. Actually, I don't think it can be 9. There are 3 ways of making up 9 in 3 cells. They are 2, 3, 4, impossible. 1, 3, 5, impossible. And 1, 2, 6, also impossible because we know there's a 6 there. So that's a 7, and it must have a 1, 2, 4 arrow. Oh, that's very handy. Suddenly popped in the nose of the clown. This must be a 5, 7 pair, not actually a pair. That was a naked single there. There's a 1 in one of those. And I failed. Oh, good Lord. I don't know what I'm doing with my mouse. Right. Oh, I've written 5, 7 in those when I meant to write 4, 7. I apologise. That's a 4, 5 pair in the first column. Now, what about this 20-something sum? Ah, and it can't be 21, 2, or 3. So it's at least 24. The maximum is 9 there and 9, 7 there. That's 25. So this is 24 or 5. There's 1 degree of freedom on the arrow, so 9 or 8 there, 9, 7 or 9, 6 here. Gosh, that's much more constricted than I'd expect. Oh, I can place 9 in box 7. It's got to be there. There, that 1, 2, 4 pair has fixed the 5, 4 pair. I should have spotted that. 3, 6 and 7 to place in row 7. Is it this? 9 or 8 there. Now, I don't quite know what to do with that. Now, what about this 10 sum? Ah, look, this sees a lot of Sudoku digits. It's going to be 3, 5, or 6. This one has a lot more license. It can be anything between 2 and 9 apart from 8. So the minimum that these can add up to is 6. The maximum is 1, 6, 9 is 16. So this is 3, 4, 5, or 6. Trying to see what must go in there, but 9, 8 is a pair that must go in there, isn't it? Yes, that was useful, getting that 3, 4, 5, or 6. But it can't be as high as 9 or 8, gives us a restricted area here. So 9 or 8 go in there, and we can fix 6 and 9 at the bottom. These are from 1, 2, 3, 4, which is beginning to narrow down the total for this 64 a bit. I still don't think it's helpful. 2, 2, 2 there. And a 2 in one of those. Oh, can we do this? This yellow is the equivalent of the 2 purples. And that is now 2, 4, 5 or 7. Well, it's not going to be 2. And the purples can't be 3 and 1. So it's not 4. Oh, it's not 5 either, because they can't be 3, 2 or 4, 1 because of those digits. So yellow is 7. And this must be a 2, 5 pair. Yes. So that's brilliantly used the purple and yellow in one fell swoop. I'm going to get rid of the colouring. 3, 6, 1, 2, 9, 5. 4, 7 and 8 to go in the box in a chocolate teapot triple. It's so useless. That can't be 5 now. Now what about this? This is getting narrowed down considerably. 2, 3, 4 or 6. Oh, well, the maximum we can put on the arrow is 166, and that's the minimum we put here. Bingo. Done. Done and done. Right, that must help everything. 1, 3, 8, 9, 7, 2. So these are from 4, 5, 6. They definitely include a 6. This is a 3, 5 pair that we can write in. That's not a 3 now. 4 or 6 here. That's, well, not a chocolate teapot triple this time, because the fact that that's a 4, 6, 7 triple gives me a 3 there. These are from 1, 4, 6 now. No, there's not a single 3 possibility or anything there. Now I'm sure the things I've done have had some effect up here. 7, that can't be a 6. Yes, that's good. So 6 is placed in this central box. 6, 6. One of those two is a 6. That one isn't. This 24, 5's not sorted out? Don't think so. 3, 8, 9. This is 2 or 5. Oh, there's some cunning triples still to resolve. These are from 3, 4, 5 in the row. 7, that 5 has sorted out this pair. So actually those triples were not that cunning. They're all getting resolved. 2 there. 4 there. I thought I was going to get boxes 1 and 7 finished. Maybe I am still somehow. Or not. Right, there's no 2 here. And that can't be 1. So it's another of these triples. That's 5 or 8. 5, 8, 9 at the top. Still hasn't sorted out this arrow. Ah. 7, 5, 1, 3, 4, 2. No, that is 6 or 8. Can't be 9 because we know 9's in one of those two. 4, 3. Oh, this can't be 3 anymore. So that's a 7, 8, 9 triple, and we can place 6 in the row. That gives us 6 down here. That gives me a 3, 7 pair, and that's going to sort out the triples in columns 2 and 3. There we go. 8, 4, they're all done. Columns 1, 2 and 3 finished. We must be close to a complete finish now, I would say, daringly. That's not a 7 anymore. 3, 7 pair, yes. 4 and 1 are done down here. That's not 4. 1, 1, we can place 1. Haven't done this dot yet. It's going to finish us up somehow. 5, 8 or 9 by Sudoku there. And this is 5 or 7. So I think it's got to be 8, 7. Yep. Well, that is going to do a job. Oh, hang on. This cell's become impossible. Ah. What have I done wrong here? Okay, let's go back a step or two. Thought I was good. Ah, look. I said that that was a 6 when it's clearly not a 6. Let's just go back to when I put that 6 in. Okay, it should be a 5. Right, so that is taking different digits out. Now, wasn't as helpful as it being a bogus 6. Or was it? I don't know. No, I started doing these. Yes, I haven't got the triples unwound in boxes 1 and 7. Right, let's have a look at the dot. 1, 8 or 9 there. They're quite extreme digits, but it can't be 1 because of that. 2, 8 or 9. This is 7 or 8. Can't be a 9 because of the given. So there's definitely an 8 on the dot, given the possibilities, and that now becomes a 6. And that's a bit more plausible. 7, 9 pair, that's an 8. And that's not. We knew that actually from the 8 on the dot. These two can't be a 6. Now we do get 6 in this position in box 9. That's going to sort out the triples. Actually, I think that's in a different way from what I sorted them out in a moment ago. But that's the correct way. That is now seen by a 7. So we are now finishing off, I think. That 8 gets the 9, 8 pair. That gets the 9, 7 pair. Sorry about the slip. That's a 4. That's a 1. 4 and 3 are done. Just 2 boxes left to finish. That is 8 or 9. So we've placed 7. The dot tells us where 8 and 9 are. And we've got 1, 2, 5 left to place. 5, 1, 2. And I haven't actually checked this addition yet, so let's check the orange. 8, 17, 22, 30, 46, 49, 54, 64. Bingo. That is the correct sum. There are our 4 squares, 5 squared, 6 squared, 8 squared, and 9 squared. None of these turned out to be a square. They were all close. That's 3 away. That's 2 away, and that's 1 away, but it is a very clever puzzle and most entertaining. Now you can see what this dot's doing. I noticed this right at the end. If that wasn't in the puzzle, the dot between those 2 cells, you'd have this 8, 9 deadly pattern to resolve. So I think that's what it's there for. But that's really nice setting. That's a clever puzzle and most entertaining. Thanks for going through it with me. Sorry about the error towards the end. As always, thank you for watching us on the channel. We are grateful and hope to see you again soon. Bye for now.